So remember, a slope-intercept equation is an equation in the form y equals mx plus b, where the value that m is multiplied by can be a whole number, it can be a fraction, it can be a positive number, it can be a negative number, but this is your slope, the m value. It's your slope, or it's also the rate of change. So in the examples that we did in investigation one, it was the rate of change of active infections per day. So that's what x is multiplied by. So if your rate of change is infections per day, x would be days, multiply the rate of infections per day by a number of days, you have a number of infections that you're adding on to whatever the starting value is usually. The other piece of our equation, mx plus b, the b is the y-intercept. And remember, the y-intercept is the point that would be on the y-axis. It's where the line representing the solutions to the equation crosses the y-axis. So at that point, y is always, x is always 0. And then the value of y we called b, or the y-intercept. Why they chose b and why they chose m, I'm not sure. But those are the traditional letters that they use to represent those in the equation. So that's your y-intercept. And this is usually some kind of a starting point. So if you're looking at a scenario, usually when x is 0, that's the starting point. It's how far you've gone at 0 hours, how much money you started with in your account at month 0, something like that. It's a starting value. And so there's only two things that we need to find when we're writing a slope-intercept equation. That's the m value and the b value. So the m value, your slope, I'm going to write this again down here. M value is your slope, and then the b value, which is the y-intercept. And so both of those can be found using a table or a graph. Often it's also included in a scenario. So the first one I usually start with is actually the y-intercept, even though it's the second one in the equation, because in a scenario, the y-intercept is often some kind of a starting value before some rate of change applies to that and causes it to change. So when you're looking for the y-intercept, you're looking for the value of y when x is 0. So you're looking for x is 0, so we're looking for that. So that means for this one, -2 would be your y-intercept. It's not always the top number in your table, though. You want to be careful. So in the second equation, the second pattern found in a table that you write an equation for, your y-intercept would be there. And in the third one in this set, your y-intercept would be there. So it's not always the first one, it's the one that goes along with x is 0, because that's the point that would be on the y-axis when you make a graph. That would be the starting value. The second part is the slope, and the slope is definitely a bit more complicated because it's a rate. It has two different units. You're looking at a ratio of two different numbers changing. You're looking at the change in y over the change in x. So remember your slope. M is change in y over change in x. So rise over run was one of the ways that we remembered how you set up your slope. It's common to accidentally flip that over and do change in x or change in y. And so when we're looking for the slope in a table, you can choose any 2 points to find your slope. So for example, in this one, I'm actually going to use these points. So 1, 1, and 2, 4, just because it's always easier to deal with positive numbers and avoid working with negative numbers if you can. But it doesn't matter which 2 points you pick. So you'll notice with this one, y goes up by 3, so from 1 to 4, with an increase of 3, when x goes up by 1. Same thing happens here. That's because it's a constant rate of change. Y goes up by 3 when x goes up by 1. Same works up here. Y goes up by 3 when x goes up by 1. So our slope for this one, m, is 3 over 1. But when it's over 1, you can just write it as 3. You can write your slope as a whole number. And so for this equation, it would be 3 times x plus -2. Or you could write this as 3x minus 2. include my y equals. So remember, I could put in any of these x values, so I could test this out and make sure it works. So if I put in the value x is 2, multiply 3 by 2, you get 6. 6 minus 2 is 4. So when using this equation, if I put in x is 2, I get y equals 4. So it works. If I put in x equals 3, 3 times 3 would be 9. 9 minus 2 would be 7. So it works for each xy pair. So that's a good way to check your work. But instead of putting in an answer key and including all the answers in this video, what I'm going to encourage you to do is use Desmos to check this, because then if you do make a mistake, you get that visual. And second of all, you have an equation, you have a table now. When you use Desmos, you'll also get the graph to represent that set of points in your table and the set of XY solutions shown in a graph. So in Desmos, let me show you how to check your work. So first, if you click on that link, you'll get a window in Desmos. It looks like this. You can apply all sorts of stuff to this graph. You can put tables in, you can put equations in, and you can change the way it looks. But we're just going to put in, first of all, the table of values that we used to write the equation. So I'm going to add a table. It gives you your x and y, and then I'm just going to put in the xy values given the table. So x is 0, y is negative 2. When x was 1, y was 1. When x was 2, y was 4. And when x is 3, y was 7. So notice when I graph those points, they all fall in a straight line because this is a linear pattern. And then the next thing I'm going to do is I'm going to put in the equation that I just wrote using that table of values. So that was y equals 3x minus 2. And notice it's correct. So if you wrote the correct equation, the points that you use to write the equation in the table are going to be on that line because those are xy solutions to the equation. Each xy pair on that line makes that equation true, oops, including the ones in between. So if I run my cursor along here and click on it, it'll give you the xy value at any point along that line. If I put in that x value, so for example, the one I'm showing now, 1.54, if I did 3 times 1.54 minus 2, I would get 2.62. So that's another xy pair that makes this true. And that's true for anywhere on here. Now, right now, my graph is only showing some of the solutions. The ones from, looks like x is about negative 2 to x is about 3. But notice, I could zoom way out and you get all these way bigger numbers, and this could go on forever and ever. And I get all these other points that also make that equation true. So if I clicked way out here, so if x was 143, 3 times 143 minus 2 would be 427. So every point on that line makes that equation true. So I've done it correct. Now, if you had done something like, let's say you flipped over your slope, you would end up with a slope, instead of it being 3 over 1, you'd have 1 over 3. And notice what happens if I do that, if I have a slope of 1 over 3. So if I do that, let me zoom in on the original points that we used. If I do that, notice what's happened is it hits one of the points. I have my y-intercept right, so it hits this point right here at negative 2. But I don't have my slope right. My slope of 1/3, remember, as the slope gets smaller, 3 to 1/3 and closer to 0, the line gets flatter and less steep. So I have a slope of 1/3 instead of a slope of 3, so my slope isn't steep enough, so it's going below all of those points. It needs to be steeper. And so if you had made that mistake, this would tell you where to look for the mistake that you need to fix in your work.